Hi, hello everyone, and welcome to this YouTube series where we'll be covering WebGPU and how to create a game with WebGPU. So, for those who don't know it yet, uh, what is WebGPU? Well, WebGPU is new API, new rendering API. It's similar to like DirectX, Metal, Vulkan. It's kind of uh, successor, if you will, to WebGL, since WebGL is not going to be actively developed anymore, at least not the new features, maybe some fixes here and there, but the new features, they kind of stopped. They said, okay, we have the WebGPU and that's going to be our new web API. Uh, that doesn't mean that WebGL is going to go away, but anyway, so why WebGPU? As I already mentioned, because it's new, it's modern API. It's similar to Metal, Vulkan, DirectX 12. So yeah, it brings new features to web, and it will continue to do so in future. For example, compute shaders were not available with WebGL. Anyway, so how does it actually work? Just to clarify it. So basically, WebGPU sits somewhere here, and actually behind the scenes, it either calls Vulkan, DirectX, Metal, or even OpenGL or OpenGL ES for embedded systems, and those APIs are calling the actually communicating with GPU. So WebGPU is kind of it's specification, right? It's similar specification to that of Metal, Vulkan, DirectX, but it actually kind of calls those APIs. So it works like that, and then you just call it in TypeScript or JavaScript, whatever you want, whatever you will. It can be completely another client, it doesn't matter, but it calls WebGPU, and you use it to render graphics. So uh, just just so that you're aware, it's relatively hard API to learn. Like every 3D API is hard. So if you're complete beginner, this is probably not the best tutorial. But if you're someone who's already experienced, maybe interested in graphics, maybe interested in game development, rendering, whatever, this is probably a good video for you, and you just want to like get to know WebGPU, what it's all about. It's kind of similar to Metal in my opinion, but I haven't really played with Vulkan or DirectX, so can't say for those, but it's probably similar. And what are we going to need for this video? So we're going to be working with TypeScript, mainly because of types, right? It will be way easier to work with TypeScript than JavaScript, so that's why I'm going to use TypeScript. It's modern language, really nice language. So yeah, I don't see why not to use it. Uh, Aside from that, you're probably going to need Node. So I would recommend to install Node. You probably already have it if you ever worked with JavaScript or TypeScript. If not, install it. Then I'm going to cover steps, what and how are we going to use it. Second step, we're going to need to have width, and maybe we can just click guide here. All right, it doesn't matter now. We're going to install it later, and then for editor, probably Visual Studio Code is good, any editor that you want. And really important thing that I always forgot to mention, since WebGPU's new API, it was released in May on Chrome, so you kind of have to take a look at browsers which support it, and right now it's Chrome, Edge, probably latest releases or releases that are not 3 months old, and Firefox only nightly build. If for whatever reason the Chrome, Edge or Firefox are not working for you, you can also take Chrome Canary. It's also development build for Chrome. So you can download it here, it works for sure here. And with that said, let's actually get started. All right, let's start it. Now, assuming that you have installed Node, it should be available in terminal. Let's just quit this here, and you can find it just like it's called terminal on Mac. On Windows it's command line or PowerShell. You're probably already familiar with it. If not, uh, well, on Mac it's just called terminal, right? On Linux it's also terminal. It's console depending on desktop environment on Linux or your distribution. And Windows, you can just use search and type PowerShell or command line, and then npm should be available. You can check it like this, npm version. And now we need to install vite, so we can say npm install globally, and then vite is our package name. And of course it doesn't work because I need to run npm sudo. So maybe I should clear the screen so that we can see what I'm working with. So we can say sudo. On Windows you don't have to do this. npm install globally and then vite. And then it's going to ask me for password. And then I'm going to have to retype password because apparently I cannot type. And perfect. It has created a folder. Yeah, my bad. I should have been in desktop. Alright, let's change to desktop and then yeah, that's fine actually. I just installed the package. Now we're actually going to run the vite command. So I'm now in desktop folder, so you can use whichever folder you want. And now I'm just going to copy this, paste this in, which will create our command is npm create vite at latest. You don't have to use at latest. And then let's just call our project WebGPU game. For framework, I'm going to use vanilla, and then for language, we're going to use TypeScript. And perfect, this has created the folder apparently, but on my second screen, let's just move it here. I also have WebGL game. This is also tutorial that I'm making, which is going to be exactly the same, only with WebGL instead of WebGPU. Alright, then we can move to WebGPU game folder, and then we can say, what can we say? Actually, we're good. We can say npm install. It's just to install dependency, and then we can say npm run dev, and that will start our local server. As you can see here, we can copy it or you can type it. And then what do we have here? We have this here, which is the default project created by vite. So we're going to get rid of it. Alright, to get rid of it, we can do this, and we can check our folder structure. So let's see. I am already opened the project here, and you can see we have this counter. We don't need counter. Let's just remove it. Delete. Get rid of the counter. So we now get error. We don't care about this either, but actually leave main ts. That's going to be our main file. We can get rid of style css. We don't need it. We can get rid of TypeScript CSS. We don't need it. This, I don't know what does this do, so I'm not going to delete it. And in index, we're actually going to get rid of div and use canvas element. Oh no, what have I done? And use canvas. ID of canvas, we can say that it's going to have width of 800, height of 600, and then we can just add some style so that we can see that it's on screen. Display, I don't care about display, let's say border black. Oh no. And border width 1 pixel. Okay, we can see border here now. So just you see border width is 1 pixel, and then border style is solid. Let's just get rid of this for now so that you can see. Alright, and with that said, we can actually start with the WebGPU. Okay, let's start with code, and here let's just get rid of this. We actually need to create our class which will represent our renderer, and it's going to be called renderer. And here we are going to have actually two methods: public async initialize, and then the second method is going to be not the render, it's actually going to be draw. And here what we need to do is just create our renderer, const render new render initialize, and then since it's async, we just need to make sure that this initialize completes, and when it completes, in then we're just going to call the draw method. So this is how we paste callback in TypeScript. Let's see further. We're actually going to need to get our canvas. Okay, fine. And then we can say actually, let's do it as a global render context. And this is going to be GPU canvas context. Oh, and this doesn't work. The reason it doesn't work is probably my TypeScript doesn't have this WebGP types since it's relatively new. So we can do this types WebGPU. And here I have terminal running. I already installed types previously, but as you can see, I started the video again. But anyway, so you can find in Visual Studio, you can go view terminal and it will open this terminal. Just clear it. And then we can use find WebGPU types and we can install those types. So let's just copy this, shamelessly copy paste it. Oh, wrong button. And then we can suit this. And here you can see in compiler options in TypeScript config file, we only need to do this once. We're probably not going to touch TypeScript config file for a while, and we need this part. Don't care about node stuff. And here we're just going to close it, and then our types should be available. And it is. Okay, and here it's complaining because it's not initialized. We can avoid it with this. Exactly, and then we can actually create it here. Now that we have it, just a note, if you're not seeing something correctly in this file, you can install extension, yeah, JavaScript and TypeScript nightly or whatever, whichever, right? TypeScript extension that you want that's going to highlight everything and have this out code suggestions. It should be by default there, but I don't remember anymore. I've been using Visual Studio for a while, and let's actually continue. So if context is not available, you can draw alert warning, and then context, get context. All right, perfect. Actually, I haven't explained context. So it's just basically an interface to canvas element. So we really only needed to configure the canvas element for drawing, and we're going to do that a bit later. But now let's focus on adapter. And adapter, you get it via navigator, and navigator is just a global object in JavaScript, which holds client information, some stuff about the client, and it holds also GPU. And then with the GPU, we can request adapter, and adapter is actually your GPU. So you might have multiple adapters. So that means you might have multiple GPUs, usually integrated and dedicated one. So we're just going to request adapter, and adapter can take some options. So it has this power preference option, which can be high performance. We're not going to need it, but high performance is if you wanna, for example, run a draw loop, right? 60 frames per second. But for now, we're going to change it later. We don't need it. We can just use low power. And what low power does is it's kind of configures your GPU for low power usage. So that's kind of hint to it. And it says, okay, we might draw only once and then we're done. So you don't need to run loop, and this low power preference will actually save your battery if you're on a mobile or if you're using a laptop. So we can leave it as here, and then if for every reason you don't have adapter or GPU, we can just say no adapter found. You should have it probably, but you never know. And then let's see. Let's see. After adapter, it goes. Yeah. We just need to configure. Sorry, looking at some of the notes, we just need to configure the canvas context, as I mentioned previously. We need to configure our canvas for drawing. We're going to pass device, which we created. But we haven't created device. I know, I forgot it. So here, let's actually say private device, GPU device, and let's create device. So here I mentioned that we actually get adapter as GPU, but this is actually the interface which this request device or this device is actually interface with which we communicate with the actual GPU. So we're going to have device here and device. Yeah, exactly. Device also has a descriptor which you can kind of ask which features do you need from the device. We're not going to get into that since it's really not necessary right now. But here we can just say this device. We're letting the canvas know about our selected device, and the format can be this one. So it's just we set the pixels of a canvas to this format, so blue, green, red, alpha. But actually, there is even better way to do it, and that's by calling navigate GPU, and then we can just say get preferred canvas. Get preferred canvas format. And that's kinda it. Let's just complete this. And I should actually do this. Let's move this a bit. This is some artifact from Visual Studio, it doesn't matter. And now the drawing actually. So for now we just configured our canvas for drawing, and we got the device, the interface which we can use. And now let's actually do something with our device. So up to draw method, how it actually works is first let's just create a command encoder, and then I'm going to explain it. This device create command encoder, and let's move this for now. And we can actually leave the texture. I'm going to get to it. But first, command encoder. So how does it work? Basically, we use command encoder to encode our commands to the GPU and then just send everything to the GPU. So basically, we're just going to say if you need to render something, we can say to command encoder or render this. Use this buffer, the buffer being the actual geometry, memory, etc. Use these shaders. We use command encoders for this, and we then just submit it to the GPU and forget about it. Texture view is kind of interesting. We need it here. Texture view is, let's explain it like this. You can see the context here, and then get current texture. So we actually get the texture of a context, and it works like this. Let's get this. So we have this canvas element. Okay, drawing with arrow. I'll remove the error for now. So we basically have this canvas element, and we might have texture here, right? And we actually draw to this texture. Uh, and then we might have sun here. This is flower, and then we use essentially that texture in canvas element. And so the texture gets applied to canvas. We have a flower here, and maybe sun here. All right. So that's what basically it is. We can also draw to some other texture which we might not even present to canvas. We might use it for post processing, etc. But that's how it works. With that said, let's go further. So we have our texture, and then we need something called render path descriptor. Render path descriptor. We need to call our attachments here. So the view is going to be our texture view. So we have this is wrong suggestion. It should be clear value. And here we just specify to which color will this canvas, this texture be cleared, and we can say maybe let's use red here for now. Then we have this load up and load. The suggestions are all wrong. Nah, nice GitHub Copilot giving wrong suggestions all the time. Good job. Anyway, I'm using GitHub Copilot, so the AI is working some of the stuff for me, but apparently not very good. Um, anyway, the load up It's just say when our texture is being loaded what to do with it, and we just want to clear it every frame. And then we also have store up. This means what do we do with the texture? We just store the colors. We're not going to discard anything. So basically this is just default. We might work with discarding later, might not, but always set it just to store up. It's probably for the best. Then let's actually just format this a bit so it looks nicer. And then here and here it's missing something. It's complaining below. And here, just looking at my node, we actually need to create path encoder. So it's beginning of render path. So we're now rendering. And then later we're just going straight draw stuff here. We don't care about it. We're not going to draw in this video. We just want to clear our screen. So we can say, you see, these are suggestions. Come on. We're going to be drawing stuff here, but we need to end our draw path. So we just say end, and then the last part is we need to submit all those commands that we have to the device, our GPU queue, and then we just submit our command encoder. And as you can see, it's done. So we have a red color here because we have defined red color here. If I say green is maybe 0.8, we get this kind of color, and then maybe blue as well, then we get really white. And since I wanna use gray for future videos, I'm going to leave it at 0, 0.8, 0.8, 0.8, and then alpha is 1.0. Okay, perfect. So this is how you do it. Hopefully you enjoyed this video. What's important? Let's see. Uh, yeah, this is general workflow how it goes, right? With the WebGPU, it's a bit of a more setup than let's say WebGL just to clear something. It is what it is. It's bit API. It's not even that much harder. It's a bit more verbose, let's say it. But it's really nice once you get to it because WebGL is really old API. It's a bit weird, wonky. So yeah, if you wanna switch WebGPU, it's probably a good choice. With that said, for the next video, we're actually going to create a triangle screen, which is kind of hello world of graphics. And yeah, that should be a good start. Just get some triangle, get to shader stuff, get to buffers, pass some stuff to the GPU. Yeah, that should be good. So until next time.